Today, we're stepping inside one of these washing factories to uncover the journey your hotel bedding takes from checkout to check-in. Before we follow the sheets to the factory, it's worth asking, why white? There are three main reasons. First, white bedding communicates cleanliness. Guests instantly feel reassured when they see spotless white sheets because any stain or mark would be immediately visible, meaning the hotel must maintain them to a high standard. Second, white bedding is versatile. It matches any room decor and can be easily coordinated with towels, pillowcases, and duvets. Finally, white bedding is practical for washing. Since it has no colors that could fade or bleed, it can be washed at higher temperatures with stronger cleaning agents, ensuring deeper sanitation. The process begins when guests check out. Housekeeping strips each bed, bundling sheets, pillowcases, and duvet covers into large cloth bags. These bags are wheeled down service corridors and loaded onto laundry carts. In larger hotels, these carts are sent directly to an on-site laundry facility. But in many cases, especially for chain hotels or resorts, the linens are sent to an off-site industrial laundry plant that handles washing for multiple properties. Once they arrive, workers begin sorting. Each item is checked for stains, tears, or damage. Linens are separated by type. Flat sheets in one pile, fitted sheets in another, pillowcases, duvet covers, and sometimes mattress protectors. This ensures that each load is washed with similar fabrics and soil levels. Before bedding is washed, visible stains are treated individually. In hotel laundry, stains can range from makeup and coffee to ink or even food spills. Workers apply specialized stain removers using brushes or spray bottles. For tough stains, they may soak the fabric in a pre-treatment solution for up to 30 minutes. The key is to lift the stain before it goes into the main wash, because once a stain is set by heat in the drying stage, it's almost impossible to remove. Unlike home washing machines, hotel laundry factories use massive front-loading washers that can hold up to 200 pounds of linens at a time. These machines are built for efficiency, capable of handling heavy loads while using precise amounts of water, detergent, and energy. The wash cycle usually begins with a cold water flush to remove loose dirt and prevent stains from setting. Then, the machine fills with hot water, often between 60 degrees and 90 degrees Celsius, 140 to 194 degrees Fahrenheit, to kill bacteria and dissolve oils. Maintaining white bedding isn't just about washing in hot water. It's about using the right combination of chemicals. A typical formula might include alkaline detergent to break down body oils and sweat, oxygen-based bleach to brighten whites without damaging fibers, water softeners to prevent mineral buildup from hard water, enzyme cleaners to target protein-based stains like blood or food, neutralizers to balance the pH and protect the fabric. The entire wash process may include multiple rinse cycles to ensure no detergent or bleach residue remains. After washing, the machine spins at high speeds to extract as much water as possible. Industrial washers can reach spin speeds up to 1,000 RPM, removing more moisture than a standard home washer. This reduces drying time, which helps preserve the fabric's strength and texture. The linens are transferred into large tumble dryers. These machines use precise heat control to avoid over-drying, which can make fabrics brittle. Some factories even use specialized dryers that inject steam at the end of the cycle to soften the fibers and reduce wrinkles. Drying temperatures are typically lower than washing temperatures, usually around 60 degrees, 140 degrees Fahrenheit, to prevent shrinkage while still ensuring sanitation. For that hotel-perfect finish, linens often go through a flatwork ironer, a huge machine with heated rollers that both dries and presses the fabric. Sheets pass through at high speed, emerging crisp, smooth, and ready for folding. Pillowcases and smaller items may be pressed separately, using smaller rotary presses or steam irons. Once pressed, linens are automatically folded by machine or by hand, depending on the facility. Some hotels require their linens to be packaged in protective plastic wrap to keep them clean during transport. Others store them in covered carts that go directly back to the hotel. Before leaving the factory, every batch undergoes quality checks. Workers look for any remaining stains, signs of wear, or damage. Any item that doesn't meet the standard is either rewashed or removed from circulation. The clean linens are loaded onto delivery trucks and transported back to the hotel. There, housekeeping staff store them in clean linen rooms, ready to be used for the next guest. In the hotel industry, hygiene is not negotiable. Industrial washing ensures that all bacteria, viruses, and allergens are removed. This is especially important for guests with sensitive skin or allergies. Some factories use ozone laundry systems, which inject ozone gas into the water to sanitize at lower temperatures. This saves energy while still killing germs effectively. Washing thousands of linens a day uses a lot of water and energy. Many modern laundry plants are adopting eco-friendly practices, such as recycling rinse water for the next wash cycle, using high-efficiency washers that use less water per load, installing heat recovery systems that reuse heat from wastewater, switching to biodegradable detergents. These changes not only reduce environmental impact, but also lower costs for hotels in the long run. If you enjoyed this behind-the-scenes look at how hotels keep their bedding perfectly white, there's a whole world of fascinating factory stories waiting for you. Hit that subscribe button, tap the bell icon, and join us for more journeys into the hidden processes behind everyday things you love. In today's world, there's a material that looks, feels, and even smells like genuine leather, but it doesn't come from cows, goats, or any animal at all. Instead, it comes straight out of factories, labs, and high-tech manufacturing plants. We call it synthetic leather, But how is this incredible material actually made? How do we transform basic chemicals and textiles into something that mimics one of the oldest and most luxurious materials in human history? And why is synthetic leather such a massive, growing industry, supplying billions of shoes, furniture pieces, and car interiors every single year? In this video, we're going to take you deep inside the synthetic leather production industry. So, grab a seat because we're about to peel back the layers on how synthetic leather is manufactured at an industrial scale. Before we dive in, don't forget to subscribe to our channel and hit the notification bell so you won't miss our deep dives into the fascinating world of how the world's essential materials are made. Now, let's get started. The first wave of artificial leather appeared in the 1920s and 1930s, when PVC-based products began to replace genuine leather in military gear, bookbinding, and upholstery. After World War II, the technology spread worldwide, giving birth to the first large-scale synthetic leather industry. By the 1960s and 1970s, faux leather became mainstream. It was affordable, versatile, and mass-producible. Shoe companies embraced it for everyday footwear. Automakers used it to upholster seats at a fraction of the cost of real leather. Sports companies adopted it for balls and protective gear. Fashion houses, at first resistant, slowly began to experiment, especially as coatings and embossing improved to make synthetic leather nearly indistinguishable from the real thing. But that brings us to the most fascinating question of all. How is synthetic leather actually made? What happens inside a production plant, from the very first raw material to the final sheet of leather-like material? That's what we'll uncover in the next part. Synthetic leather isn't built from plastic alone. At its core, it needs a base material, usually a textile. Common backings include polyester, nylon, or cotton fabrics. The fabric is chosen based on the final application. Thick, durable textiles for car seats and furniture, light, flexible ones for fashion and apparel. These fabrics arrive in huge rolls, sometimes stretching hundreds of meters. Workers load them onto machines where they are cleaned, tensioned, and prepared to receive coatings. The purpose of the backing is simple. It gives synthetic leather strength, flexibility, and structure. Without it, the plastic layer would tear too easily. In the factory, technicians mix the polymer granules with plasticizers to make it flexible, stabilizers to resist heat and UV, and pigments for color. The result? A thick liquid or paste known as a polymer solution. This solution will soon be spread across the fabric to form the top layer of synthetic leather. Now it's time to merge fabric and polymer. The textile backing passes under a coating head, where the liquid polymer is spread evenly across its surface. In wet coating, solvents are applied and then evaporated in a heated chamber, leaving a smooth layer of PU on the fabric. In dry coating, the polymer is melted and directly applied, then cooled to solidify. The goal: create a uniform, smooth surface that will later be textured to look like leather. After coating, the material moves through long heated tunnels, sometimes over 50 meters in length. Inside, heat and airflow evaporate solvents and cure the polymer. What was once a sticky liquid now becomes a solid, durable surface. This stage is critical. If the temperature is too high, the polymer may blister. Too low, and the layer won't cure properly, leading to poor durability. This is where the magic happens. Raw coated fabric looks smooth and plastic-like, nothing like real leather. To transform it, factories use embossing rollers engraved with leather grain patterns. The sheet passes through heated steel rollers that press the texture deep into the surface. This step gives synthetic leather its authentic look and feel. Next, the material is refined for aesthetics and performance. Pigment coatings are sprayed or rolled on for exact color matching. Protective top coats are added to improve water resistance, UV protection, and scratch durability. Gloss or matte finishes are applied depending on design requirements. Factories can also adjust softness by controlling the polymer blend, creating either stiff industrial leather or buttery soft fashion leather. After embossing and finishing, the synthetic leather is cooled, inspected, and trimmed. Large sheets are cut into rolls. Each roll may be 30 to 100 meters long and over a meter wide. These rolls are then wrapped, labeled, and shipped to manufacturers around the world. Shoemakers, car companies, furniture brands, and fashion houses will use these rolls to create the products we see every day. No batch leaves the factory without testing. Only after passing these rigorous checks does synthetic leather reach the market. In just a few hours inside a factory, plain fabric and chemical polymers are transformed into something indistinguishable from natural leather, but more affordable, scalable, and versatile. Synthetic leather is more than just a material. It's the story of human ingenuity. From the challenge of limited animal hides to the creation of scalable, versatile alternatives. It's a story of fashion and function, science and society, ethics and innovation. If you found this journey into the world of synthetic leather fascinating, don't forget to hit that like button, share this video with a friend, And of course, subscribe to our channel for more mind-blowing stories about how everyday things are made. Your support helps us keep exploring the industries that shape our world. Every day, in millions of kitchens across America, one name keeps sizzling on stovetops: Calphalon. Sleek, durable, reliable. But while most of us only see the final product, a beautifully polished pan or pot, few ever witness the fiery, high-tech journey behind it. If we told you that what starts as a heavy chunk of raw aluminum will soon become a professional-grade piece of cookware, forged by 10,000 pounds of pressure, hardened with a technology borrowed from the aerospace industry, and finished by robotic arms with millimeter precision? Long before Calphalon became a household name, it began as a modest industrial operation in the heartland of America. In 1963, a man named Ronald M. Kasperzak founded the commercial aluminum cookware company in Perrysburg, Ohio. His mission was simple, but visionary: bring professional quality cookware once reserved for chefs and institutions into the homes of everyday Americans. For the first few years, the company focused on producing aluminum cookware for restaurants and culinary schools. But Kasperzak had his sights set higher, on something that would redefine modern cookware entirely. That moment came in 1968. Drawing inspiration from aerospace technology, Calphalon pioneered the use of hard anodized aluminum in cookware, a process that not only strengthened the metal but made it more resistant to corrosion and wear. For the first time, home cooks had access to cookware that rivaled the performance of what professionals used in Michelin-star kitchens. And with that, the Calphalon name was born, representing a fusion of calcium, aluminum, and innovation. Throughout the 1970s, 80s, and 90s, the brand expanded rapidly, becoming a fixture in American wedding registries, holiday gifts, and college move-ins. By the time Newell Brands acquired Calphalon in the early 2000s, the company had already earned its place as one of the most trusted names in cookware. But even today, more than 60 years since that small Ohio factory opened its doors, Calphalon's commitment remains the same: professional performance made accessible. The story of every Calphalon pan begins not in a kitchen, but with a solid disc of raw aluminum. Rough, cold, silent, but full of potential. This aluminum isn't just any metal. It's specially selected for its purity, conductivity, and durability. Calphalon uses heavy-gauge aluminum, thick enough to withstand decades of cooking, yet light enough to handle with ease. Each disc is precision cut, then sent down a line where the real transformation begins. Using a hydraulic press exerting up to 10,000 pounds of force, the aluminum is drawn upward and outward into the basic shape of a pan or pot. This process is known as deep drawing, a controlled stretching technique that ensures even wall thickness from base to rim. This is where form meets function. The pan isn't just shaped for looks. It's engineered to distribute heat evenly, eliminate cold spots, and survive the kind of daily punishment home cooks and chefs alike deliver. Once formed, each piece undergoes precision trimming and smoothing. Sharp edges are machined down, surfaces are leveled. Then, robotic arms and CNC machines take over, milling the base perfectly flat for optimal stovetop contact, and carving in details that make each piece unmistakably Calphalon. Shaped, smoothed, machined to perfection. But raw aluminum alone isn't enough. It scratches, it corrodes, it ages. To become true Calphalon, it must go through a transformation born in science and sealed by electricity. Enter the hard anodizing process, a technique originally developed for aerospace applications, now adapted to the kitchen. Each formed pan is submerged into an electrolytic acid bath, where it becomes part of a high-voltage electrical circuit. As current surges through, the surface of the aluminum begins to oxidize, on purpose. But this isn't just rust. This is controlled oxidation, a chemical reaction that creates a new layer, up to 3 times harder than stainless steel, bonded directly into the aluminum itself. The result? A dense, microscopically porous surface that resists scratches, corrosion, and wear. It's not coated, it's transformed. The metal itself becomes stronger, more durable, and far more resilient than before. And unlike traditional coatings, this layer won't peel, chip, or flake off. It's It's built to last, for years, even decades. At this point, the cookware already looks sleek, matte black or dark gray with a satin finish. But for some product lines, there's still one more layer to add: non-stick. For some, cookware isn't just about durability. It's about the perfect flip, the flawless glide, the effortless cleanup. After hard anodizing, select Calphalon lines move into one of the most carefully controlled areas of the facility, the non-stick coating chamber.